Hey Year 11, we've been doing arithmetic sequences for a while and I just wanted to make a video to kind of recap everything because it may seem like there's a heap of things that we've covered, but I just wanted to kind of go down to basics and show the things that we really need to know. Uh, Alright, so an arithmetic sequence, they're a sequence of numbers that either go up or down by the same amount each time. So the same amount here is the really important part. So we've got a few examples down here. So with this one, we start with 2, and do we see how we're going up by 2 every time? So we go 2, 4, 6, 8. So this one is an arithmetic sequence because we're going up by the same amount each time. If we look at the next one, we go 18, 15, 12, 9, 6. Hopefully you can see that we're going down by 3 each time. So it's the same amount each time. So that would mean this is an arithmetic sequence as well. But this one here, we're going up by 2, then 4, then 8, then 16. See how it's not the same amount each time? So this one here is not an arithmetic sequence. Now, one of the really important parts of arithmetic sequences is the common difference, and they use the letter D to symbolize it, and it's the amount that it goes up or down each time. So this one here, that was going up by 2 each time, so D would be 2. This one here was going down by 3 each time, so D would be minus 3 because it's going down by 3. Okay. All right, let's move on to this next little bit here. Okay, so I'm just going to read the first dot point. So because arithmetic sequences go up or down by the same amount each time, their graphs will appear linear, which means a straight line. So these are the two arithmetic sequences that we saw earlier, and I have graphed both of them. So when we graph them, down the bottom we have the term number. So you can see term number 1, 2, 3, 4, 5. Same over here. And I've labelled that there with n, the number. And up here we've got the value of each term. Okay, so I've done little notches, but I haven't written all the numbers because it'd be too crowded. But I've graphed this sequence here. Hopefully we can see that it's going up by the same amount each time, so it's a straight line of dots. Same over here. This one's going down by the same amount each time, so it's a straight line. That's what we mean by linear. Okay. Right, let's move on again. Alright. So sometimes we want to find terms that are really far along into a sequence. It takes ages to work whole sequences out, so we do use this formula here instead. Like for example, if I wanted to find the 100th term, it'd take me forever to work out the 99 before it, but we don't actually have to do that. So we can use this formula here. So I just want to go over what each of these things mean, what each of the letters mean. Right, so n is the number of the term that we want. So if we want the 50th term, n would be 50. If we wanted the 70th term, n would be 70. A is the first term in the sequence, and D is the common difference that we spoke about before. So with this example here, they're telling us that the first term is minus 10, the common difference is 6, and we want to find the 21st term. So we're going to use this formula here to do it. So we want to find the 21st term, so that's T21. Now we need to plug these things in. So A goes in there. So minus 10 goes in there. Plus n minus 1. Now what was our n value? 21. So 21 minus 1. And we want to times that by the common difference, which is 6. Okay, so the 21st term, once we work all this out, is minus 10 plus 20 times 6 to 120. So the 21st term should be 110. And you could just type that into your calculator and it'll give you the answer anyway. I've done it by hand, but you can use your calculator, that's fine. So now we'll look a little bit into applications of these arithmetic sequences. And applications you'll find often involve money. Okay, now a couple of things they often ask are about simple interest or flat rate depreciation. Now simple interest is where you earn or pay the same amount of interest each year. So it could be going up or down, it'll let you know. And flat rate depreciation is where the value of an object is going down by the same amount each year. So again, these are both arithmetic sequences because the change is the same amount each time period. All right, now let's have a bit of a look at a simple interest problem here. All right, now here's a formula that you can use to calculate the amount of interest. Now I've written it in full words just to sort of make it a little bit more clear in what we're supposed to put in these different spots. You can write it as just letters as well, that's fine, but I think it's a little bit more clear if I write it this way for now. Alright, now let's use this formula to try and work out the amount of interest that's earned. Right, so calculate the interest earned on a $400 investment with a 5% interest rate for a period of 4 years. We just need to put all that info into this formula here. So we're trying to work out the amount of interest, and it's the amount invested, which is 400, multiplied by the interest rate, which is 5%. Now you just write it as like a full number there. So if it's 50%, you'd write 50, but we've got 5%, so we write 5. And then we need to times it by the length of time, and they told us that's 4 years. There we go, and divide all that by 100. Now if you put that into your calculator, or you can do it by hand, whatever you like, the answer comes out to be 80. So that would mean $80. So that would mean over that 5-year period, it's earned $80 interest. Okay. Now we've used this rule here, but you can kind of do it without using the rule as well. So let me just kind of set it up over here. So we might have started with how much? $400 it's told us. $400. And we want to know how much interest has been paid by the end of 4 years. So this is at the end of the first year, at the end of the second year, at the end of the third year, at the end of the fourth year. Okay, now I'll put this in a little table. All right. Now it's told us that the investment is earning 5% interest each year. So 5% of 400, so 400, and if I want to work out 5%, I need to just times that by 5%. But if you change percentage to a decimal, 5% is 0.05, and that is $20. 20. Okay, so that means each time it's going up by 20. So that means we're starting at 400. At the end of that first year, it's going to be 420. At the end of the next year, because it's going up by the same amount each time, it's going to be 440. Next year is going to be 460. The next year is going to be 480. All right, so if we started with 400 and we end with 480, that means we've earned an extra $80, haven't we? So you see how that works both ways? So you could use this method if we don't need to work out too many years down the track. But if they ask for like 100 years or 50 years or something really big, it's a good idea to use this one, because you don't want to have a massive table with 50 or 100 or however many columns. Okay, but it works both ways. Let's go to the next bit, which is flat rate depreciation. Now, there's a rule for this one as well, which I've got written in blue. So again, I've explained what each of the letters mean. Now it's a V there because we're really talking about value. Okay, so it's the value at a certain time. Now V0, that means the starting value, as if the time's 0. N's the time that we're after, that we're looking at, and D is the common difference. All right. Now let's use this formula here to try and solve this problem. All right. Now, a machine costs $50,000 when it's new. It depreciates at a flat rate of $5,000 per year, which is the same as 10% of its initial value. So it goes down 10%. Find its value after 6 years. Okay, so let's work out these things so we can actually use the formula to work out what we want. So its initial value, VO, is 50,000. Its end value, which is the time we want to know after 6 years. And D is the common difference. So how much is it going down by each time? So it looks like it's going down by 5,000. All right, now you might think, oh, shouldn't D be minus 5,000? Not with this formula, because they've already taken into account that it's always going to be going down. So if you change that to a minus, the value will be going up. Okay, so when we're talking about flat rate depreciation and you're using this formula here, keep your D as positive. Okay, so let's put these numbers in. So we want the value in the times 6. Next thing is the starting value, is 50,000, minus our n, which is 6, and times by our common difference, which is 5,000. Alright, so the value after 6 years would be 50,000 minus 30,000. So the value after 6 years should be 20,000, and that's in dollars. There we go. So there we go. We've worked that out. Now, again, you don't necessarily need to use the formula. Like, I can just do this by working out the starting price, the price after 1 year, etc. So let's do the same thing as what we did with this example earlier. I want to know the starting price, and that was 50,000. I want to know the price after 1 year, 2 year, 3, 4, 5, and 6. I probably don't have enough room in these boxes, but I'll give it a go. Alright, so we start with 50,000. It's going down by 5 each year, so that means this next one's going to be 45,000. If we go down another 5, it's going to be 40,000. Go down by another 5, it's going to be 35,000. Then 30,000. Then 25,000. And then 20,000. See how after 6 years it's 20,000? After 6 years it's 20,000? Either way is totally fine, but if you're looking at big numbers, you're better off doing this way, because doing this table is going to take forever. And the last thing I want to have a look at in this recap is recurrence relations, which it seems some people are a little bit scared of, but trust me, they're not that scary at all. So a recurrence relation is a rule that helps us create a sequence. Okay, so they tell us two different things, and that's the common difference and a single term in the sequence. Now, you might be given stuff like this. Now, this is our recurrence relation. Now, it's telling me that the first term is whatever value this is. It's not going to tell you A, it's going to give you an actual value. And this bit here, I've said this a couple of times, this means the next term is equal to the current term plus the common difference. So the main things that this is telling us are this bit here, which is a term in the sequence, and the other really important part is this bit here, which is the common difference. Okay. All right. Now let's actually use one of these recurrence relations in this next example here. So it says find the first 6 terms of the sequence described by the following recurrence relation. So this is the recurrence relation, and it's telling us that the third term is minus 4, and this bit's saying that the next term is equal to the current term minus 3. We need to start with this though. Now what I might do is I want to find the first 6 terms, yeah? So I'm going to actually show my 6 spots. So that's going to be my first term, second term, third term, fourth term, fifth term, and sixth term. And I'll actually label them as well. That's T1, that's T2, etc. Okay. Now they told us that the third term is minus 4. Cool, so we've filled that one in. Now this is saying that the next term is the current term, same as the current term, but take away 3. So it's going down 3 each time. This is what we're really looking at, the common difference. So if we're at minus 4 and we're going to go down 3, that gives us minus 7. If we're at minus 7 and we're going to go down 3, that gives us minus 10, and then minus 13. But we need to get these ones as well, don't we? Okay, so if we're going this way and we're going down 3, if we go this way, we're going to be going up 3, aren't we? Because if we got minus 13 to minus 10, we're going up by 3. From minus 10 to minus 7, we're going up by 3. So from minus 4, and we go up by 3, that gives us minus 1. And if we want to get to here, we're going up by 3. That gives us 2. There we go. So this information here was enough to create this whole sequence. And we could continue going on this way, if we wanted to, if we're asked to, and we can continue going on this way if we're asked to. But this is supposed to be the first term, so you wouldn't keep going that way. Okay. Hopefully that cleared up a few different things. Yeah, if you have any questions or you're not sure about any of these things, always feel free to ask, because I'm happy to help you out.